Alright, and we are now live here in our YouTube platform for our online discussion for our Science 10 class. Good morning, everyone. I hope that you are very well and good. Welcome to our Science 10 follow-up class discussion for this week. For your attendance, it will be monitored by yours truly and your designated focal persons. Make sure to click the Google Forms link later, which would be open after our class session. Make sure to take a screenshot of our ongoing YouTube platform, for it would be attached later on in the Google Forms link. Afterwards, do not forget to take a screenshot of the verification response, which would be sent later on in our group chat. With that, let us all pause for a moment and allot at least 10 seconds of our time to be given upon him. Amen. So, how are you, everyone? So, I'm seeing already that we have participants tuning into our YouTube platform, hoping that we would be enjoying our discussion for today. And as we do so, please be mindful of our online etiquette rules. You may share your insights here in our live chat. Without further ado, let us have a recap now of what we have discussed primarily last time regarding the said topics, particularly combined gas law, Dalton's law of partial pressures, Avogadro's law, and ideal gas law, through a game which we would be calling as the game show experience. So basically, in this game, all you have to do is to choose the best answer. So hopefully you are ready by now. Again, all you have to do is to choose the best answer. Let us begin. Choose the best answer in the answer grid. The formula is P sub 1 V sub 1 over T sub 1 is equal to P sub 2 V sub 2 over T sub 2. Would that be A, Avogadro's law, B, combined gas law, or C, Dalton's law of partial pressures? Do you have any idea on the said question? So if we will be choosing the best answer in the answer grid, that is none other than letter B. Nice one. Very good. So it is indeed combined gas law. Nice one. Moving on to our next question. If the formula is P sub total is equal to P sub 1 plus P sub 2 plus P sub 3, what would that probably be? Is that A, Avogadro's law, B, combined gas law, or C, Dalton's law of partial pressure? Is that A, B, or C? Alright, I'm looking to my other screen and you got it correctly. Indeed, it is letter C, Dalton's law of partial pressures. Moving on to our next one. If the formula is V sub 1 over N sub 1 is equal to V sub 2 over N sub 2, what would that probably be? Is that A, Avogadro's law, B, combined gas law, or C, Dalton's law of partial pressure? So based upon this, the correct answer is letter. Alright, that would be letter A, which is Avogadro's law. Alright, nice one. Moving on, regarding Boyle's law. We are tasked to find out the formula for Boyle's law. Is that A, P sub 1 V sub 1 is equal to P sub 2 V sub 2? Or B, V sub 1 over T sub 1 is equal to V sub 2 T sub 2? Or C, P sub 1 over T sub 1 is equal to P sub 2 over T sub 2? Any idea on what this would probably be for Boyle's law? The formula involved in here is, alright, that is letter A. P sub 1 V sub 1 is equal to P sub 2 V sub 2. Moving on, regarding the relationship of volume and mole this time. What do you think would that be? Is that A, directly proportional, B, inversely proportional, or C, there is no relationship between volume and mole? Is that A, B, or C? Let's see. Alright, so initially the answer in here would be A. Let's move on now to the next one. If the discoverer is Benoit Paul Emile Clapeyron, what would that probably be for its gas law? Is that A, combined gas law, B, ideal gas law, or C, both A and B, which are combined gas law and ideal gas law? Any idea? Alright, that is letter C, both A and B, which would be combined gas law and ideal gas law. And finally, what would be the universal constant for gas, particularly the numerical figures? Because we know for a fact that the unit involved in here would be liter atmosphere over mole Kelvin. But we are tasked to find out the numerical figures. Is that A, 0.0128, B, 0.0281, or letter C, 0.0821? The correct answer is letter C. Alright, very good everyone. So I was looking into our live chat and you were able to correctly respond to our previous topic. So hopefully we're able to recall our previous discussion regarding the different gas laws. Now, I would like to know your favorite food. Will you please type it in our live chat? As you are typing that, I would be sharing mine. My favorite food would be tortang talong, samgyeopsal, of course, because we love Korean dramas and Korean foods and their culture. I also somehow love kimchi rice, and my most favorite right now would be chicken wings, especially if there are different and several flavors. How about yours? What would be your favorite food? Alright, so some said sinigang. How about the rest of you? So as you're typing that, we have their hamburger, pizza, sinigang, kimchi rice. What else? So anyway, you're sharing your favorite foods like adobo, alright. There you go. So in these favorite foods that you're mentioning, are you aware that your food contains biomolecules? These foods that you're mentioning right now really do contain different biomolecules, just like carbohydrates, proteins, lipids, fats, and we will also be including nucleic acids. So you were sharing that you also like donuts, ice cream, spicy fried chicken, french fries. You also have their spaghetti, burger, adobo, noodles, kimchi, burger, and pizza. And we will be finding out more of these foods as we deal with biomolecules, in which we'll be dealing with this general objective we are seeing from the screen and its specific objectives. So there. Based upon our Valenzuela Live yesterday, we were able to know that these biomolecules usually includes carbohydrates, lipids, proteins, and nucleic acid. But what do we actually mean to say by biomolecules? When we say biomolecules, these are also known as biological molecules, and these are chemical compounds being found in living organisms. At the same time, these include chemicals that are composed mainly of carbon, hydrogen, oxygen, nitrogen, and even phosphorus. These biomolecules are considered to be the building blocks of life and perform important functions in living organisms. The biomolecules family, which we said a while ago, would be including carbohydrates, lipids, proteins, and nucleic acids. One of the many biomolecules would be carbohydrates. When we say carbohydrates, this refers to the major source of energy that our body needs. The elements present in here would be carbon, hydrogen, and oxygen. If you will be looking closely, carbon, hydrogen, and oxygen, as you combine these three, will be carbohydrates itself. And as we made mention of that, the general formula involved for this would be C6H12O6. And the four primary functions of carbohydrates in the body are first, to be able to provide energy, to be able to store energy, to be able to build macromolecules, and of course, to spare protein and fat for other uses in our body. Hence, the very reason why these carbohydrates are truly essential to all living organisms. As a matter of fact, these carbohydrates are macronutrients. What do we mean to say by macronutrients? It is how our body is obtaining the said energy and the calories being needed. Some of the other sources primarily involved for carbohydrates would be sugar, fruits, vegetables, rice, and milk. Initially, there are three main classifications of carbohydrates, and those would be monosaccharides, disaccharides, and polysaccharides. When we say monosaccharides, it literally means one and sugar. Why? Mono means one and saccharide means sugar or sweet. Thus, when we say monosaccharides, this refers to simple sugars. Thus, as we move along to the next one, which is disaccharides, it means di, two, and saccharides itself would be the sugar or sweet. And in here for disaccharides, it means to say that there are two monosaccharides undergoing a dehydration reaction, or what we call as the condensation reaction. Finally, or lastly, would be polysaccharides. For polysaccharides, it would be referring to how many saccharides are already present. Poly, which means many. And this could be either a branched polysaccharide or unbranched polysaccharide. Let us get to know more of these saccharides, beginning with monosaccharides, or the so-called simple sugar. So usually, these monosaccharides has the number of carbons ranging from 3 to 7, and at the same time, its name would be ending with the suffix OSE, like aldose and ketose. At the same time, we also have other common monosaccharides like glucose, or what we call as the blood sugar. This glucose or blood sugar are initially present in the different hospitals, like the dextrose being placed with you in the hospital if you are lacking electrons or fluid into your body. It is also placed when you are about to be operated and helps you keep going for not to be dehydrated. Moving along, we also have other common monosaccharides like galactose and fructose. This time, let us focus our discussion with disaccharides, or the two monosaccharides that are combined all together. I would like you to observe the figure. As we are observing right now the figure, we will be able to notice something. Let's begin. If we combine glucose to another glucose, that would be maltose. And we know that glucose is a monosaccharide. Thus, if we combine one monosaccharide to another monosaccharide, we will be having a disaccharide, and that is maltose. At the same time, we have here glucose combined with fructose would be resulting into sucrose. And finally, if we combine galactose with glucose, that would be resulting into lactose. So these disaccharides are being formed by dehydration synthesis from two monosaccharides, or what we have made mention a while ago, through the process called as condensation reaction or the dehydration reaction or synthesis. And some of the common disaccharide examples would be the following. We have their lactose, which are usually found in milks. We also have maltose, or the so-called malt sugar, found in grains and cereals, and sucrose, which is the table sugar itself. This time, we will be moving on to the last classification, which is polysaccharide. When we say polysaccharide, this refers to a long chain of monosaccharides linked with glycosidic bonds, which is known for a fact as polysaccharide. And some of the common polysaccharides would be including starch and even glycogen. We also have cellulose. Why is it not moving? Okay, there. So there. Those are the different common polysaccharides, which are starch, glycogen, and even cellulose. In relation to that, did you know that it is possible for us to know whether these carbohydrates are really present in the food that we are intaking? And it is possible through the different oxidizing agents or the different test solutions. These test solutions would be responsible to determine whether there really are indeed a presence of a carbohydrate. Just like what was made mention in the Valenzuela Live, some of the common test solutions in determining the presence of carbohydrates would be the following. First, we have the Benedict solution that is being used to test whether there is a presence of a reducing sugar. If it would be remaining blue, it means there is none present. If it would be changing into green or yellow, that would be resulting that there are minimal traces of reducing sugar. And if it would be turning into orange, red, there are moderate reducing sugar. And if it would be resulting into a brick red color, there is a large amount of reducing sugar. Another testing solution would be the Fehling solution. In this Fehling solution, if it would be remaining in color blue, that would mean to say that no change has occurred. But if it has changed into this orangey or reddish brown color, that means to say that there is a reducing sugar, particularly glucose or fructose. And finally, the iodine test is the test being used to determine whether there is a presence of a starch. If it is positive and changing in its color, then there is a presence of starch. If it is negative, then there is no presence of starch. What do I mean to say by that? This iodine solution is being used to be able to detect the complex carbohydrates, just like starch. And the yellow-orange iodine will be turning into blue-black, as it reacts with starch. And if there is no change in color, that means to say there would be no presence of these carbohydrates, or there are only simple carbohydrates present. Now that we were able to understand further regarding carbohydrates, let us now proceed with another biomolecule which we would be calling as lipids. Lipids have the job of storing energy for later use, and it stores in the form of fat molecules in the body to be able to be used later. And these are composed of the elements carbon, hydrogen, and oxygen. Initially, these lipids are molecules that are containing hydrocarbons, hydrogen and carbons, and make up the building molecules of the structure and even the function of the living cell. And these are oftentimes being classified into the simple lipids or the complex lipids. Example of these lipids would be including the following. We have there fats and oils, waxes, phospholipids, and even steroids. So let's go over them one by one, starting with fats and oils. For fats and oils, it could be further subdivided into two, which are the saturated fatty acid and the unsaturated fatty acid. Some of the common examples of these two would be presented in here. Starting with the saturated fats. So for saturated fats, that would be including fatty meat, lard, beef tallow cheese, butter, cream, coconut oil, palm oil, and even cocoa butter or cocoa butter. Then, as for unsaturated fats, this would be including olives, peanuts, canola oil, avocados, almonds and hazelnuts, pecans, pumpkin seeds, and even sesame seeds. Another type or example would be what we call as the waxes. And these waxes could be found in the feathers or furs of different animals and in the leaves itself. Another example would be the phospholipids. When we say phospholipids, these are esters of glycerol, fatty acids, and phosphoric acid, and even other alcohols. And finally, for another example of lipids would be the steroids. When we say steroids, this refers to the man-made version of chemicals known to be as the hormones. And these are naturally present in our body, but these are being done man-made. And these steroids are being designed to act like our hormones to be able to reduce inflammation. They're also known as the corticosteroids and are different to the anabolic steroids being used by the bodybuilders or even the athletes. So take note that that's different. Anyway, let's move on now to another biomolecule, which would be protein. Protein would be the second most common molecule found in the human body after water and make up about 10% to 20% of the mass of a cell. And they are being found in the skin, in the form of collagen, in the nails, hair, and even outer layer of our skin in the form of keratin. And they are mainly composed of elements like carbon, hydrogen, oxygen, and nitrogen. So to put it simply, this protein refers to the building blocks of our life. Every cell in our human body is containing these proteins. The basic structure of a protein is composed of a chain of amino acids. They are mainly composed of elements like what we've mentioned, carbon, hydrogen, oxygen, and nitrogen. To be able to control the production of the protein, that is where the nucleic acids would be coming in. We know for a fact that in the previous quarter, we somehow were able already to discuss what we meant by nucleic acids. And these nucleic acids are the molecules that are responsible for the hereditary traits that we are generating amongst our body. At the same time, last quarter, we were also able to determine and differentiate DNA from RNA. Do you still remember the difference between DNA and RNA? So DNA, of course, stands for deoxyribonucleic acid, and RNA stands for ribonucleic acid. Both of these are considered to be important molecules of our body, and to be able to differentiate them, we have here a table. So both DNA and RNA are considered as nucleic acids, which has a chain of pieces called as nucleotides. It has three parts: the sugar, the base, and the phosphate. If we will be describing the DNA, it is containing two strands. That's why it's called as the double helix. The sugar involved in here would be deoxyribose, and the four bases are the CGAT: cytosine, guanine, adenine, and thymine. And these are located particularly in the nucleus of the cell. As for RNA, ribonucleic acid is only a single strand. In this single strand, the sugar involved would be ribose and the bases would be CGAU: cytosine, guanine, adenine, and uracil, which are located in the cytoplasm of the cell. So there you have it. Those are the different biomolecules, particularly carbohydrates, lipids, proteins, and nucleic acids. This time, in our activity, try to determine whether the food being described or the statement being described contain carbohydrate, lipid or fats, or protein. So to make it easier, you may just simply write down C, L, or P. Let's begin with this one. Bread. Is that C, L, or P? Carbohydrate, lipid, or protein? Let's see. Alright, nice one. You have typed it in already. That is indeed C, carbohydrates. Moving along, we have here potato. Is that carbohydrate, lipid, or protein? For potato, that is letter C, carbohydrates. How about this one? Olive oil. Is that carbohydrate, lipid, or protein? Okay, I'm seeing it already. Nice one. Indeed, that is letter L, lipids. Next, chicken meat. Is that carbohydrates, lipids, or proteins? Wow, you're typing so fast. So in here for chicken meat, actually, there are two probable answers. It could be lipid or protein, but most of the time it is protein. Next, spaghetti. Is that carbohydrate, lipid, or protein? So for spaghetti, that would be carbohydrates. Alright, let's move on. Next would be butter. Smooth like butter. Alright, whatever. Anyway, stream butter. Just a commercial. For butter, would that be carbohydrate, lipid, or protein? So that is letter L, lipids. Next, fish. Is that C, L, or P? Carbohydrate, lipid, or protein? Allow me to check again my other screen. Okay, nice one. Well, in here for fish, it could be lipids or proteins, but most of the time it is protein. How about beef? Is that carbohydrate, lipid, or protein? For beef, that would be protein. Nice one. How about for cooked rice? Any idea for cooked rice? Is that carbohydrate, lipid, or protein? So for cooked rice, that is carbohydrates. A while ago, you've made mention that pizza is one of your favorite foods. Would that be carbohydrates, lipids, or proteins? So initially, pizza would be carbohydrates. Nice one, guys. Love it. So this time, let's analyze. If it is considered to be the main source of energy in our body, would that be carbohydrates, lipids, or proteins? The main source of energy in our body is none other than but carbohydrates. How about this? If it would be including sugar and starch, what would that be? For sugar and starch, that would be included in carbohydrates. How about this one? It is making up our muscles, skins, or skin, and even our bones. Is that carbohydrate, lipid, or protein? Nice, that is B, protein. Alright, a while ago you've made also mention of this one. Hamburger, is that carbohydrate, lipid, or protein? So actually for hamburger, it could be carbohydrate, lipid, and protein at the same time because of the different ingredients present in there. But most of the time, it is carbohydrates. How about this one? It is made up of amino acids. Is that carbohydrates, lipids, or proteins? So if it is made up of amino acids, that would be protein. So there you have it. We were able to understand the different biomolecules, and let us sum up what we have tackled for today. To begin with, biomolecule is any molecule that is being produced by living organisms, including large macromolecules such as carbohydrates, lipids, proteins, and nucleic acids. To begin with, we have their carbohydrates. Carbohydrate is a biomolecule that is responsible for supplying energy for our body and are the primary fuel source for the brain's high energy demands. It could be classified into monosaccharides, disaccharides, and even polysaccharides. As for lipids, it is responsible for storing and supplying the energy for later use, and it could be classified into either simple lipids or complex lipids. Another biomolecule would be proteins. These proteins are responsible for rebuilding our body system, and it is allowing metabolic reactions to be able to take place. Initially, the nucleic acids are serving as the storage and expression of the genetic information which is making up our proteins. In these nucleic acids, it is being subdivided into two, which are DNA and RNA. DNA, which stands for deoxyribonucleic acid, and RNA, which stands for ribonucleic acid. So hopefully you were able to understand biomolecules, and to check your understanding, we know for a fact that these biomolecules could be detected by different means. It could be through physical and even chemical tests. So there, let us now check your understanding through a game which is quizzes. So I will be stop sharing for the meantime to be able to share my other screen for a while. So we would be playing a game called as the quizzes, and in this quizzes, of course, you're very much aware of this already, that as we play the said game, we will be opening another browser and click joinmyquiz.com. As you type joinmyquiz.com, make sure that you will be typing the code. So we have here the code, which is 455806. 455806. Again, joinmyquiz.com, and the join code would be 455806. So we have already 5 players and counting: Joshua, Danica, Charla, Zyram, Janzel, Miguel, Ronald, Abigail, Pearl, Sean, Jov, John Paul, Gian, Mary Louie, Trisha, Kate, Melvin, Setiel, Manuel, Andrea, Roger, Jonalyn, Rhea, Jay-Z, Apple, Larry, Jaire, Ashley, Marielle, Melbert, Jerome, Zarina, Bea, Ivan, Marian, Janus, Christine, Doreen, Ezra. So far we have 46 players, including Mark and Lizelle. So let us now begin the game. So make sure to look on your own screens to be able to answer our questions. Have a good time while I'm looking upon the tally of scores. All right, nice one. We will be ending the game shortly. All right, 5, 4, 3, 2, 1. Okay, let's see our top scorers. Oh, where is it? I was not able to see it, but I will be checking it later on. Wow, it's missing. Anyway, our top scorers, our top 20 scorers would be receiving high scores. In fact, they would be able to, our top 20 scorers would be able to receive the highest scores for our recitation, and our top 3 scorers would be receiving a prize. So I will just be showing it to you later on. I'm so sorry for the inconvenience that has occurred. So allow me to reshare my other screen. So once again, congratulations to our top scorers, in which I will be checking later on. For our top 3 scorers, you would be receiving a corresponding amount into your GCash number. Anyway, here is our food for thought this week. You'll get there, don't give up. We are already about to end your grade 10 or your junior high school journey. Please do not give up. I know that some of you are already hesitating or somehow a bit tired already of the circumstances that you are facing. But I believe in you that you will be continuing as you grow, as you learn. And please be aware of that it's okay to rest for a while. It's okay that you are not always at your best. I have read yesterday in an article of a Facebook page in Millennials for Christ. Anyway, I'm just sharing this, that resting is working too. You don't have to force yourself too much because rest is as important as studying. So just be aware that you are validated, you are worthy, and you will be getting there. Anyway, thank you so much, everyone. I had a great time. I will be saying later on our top 20 scorers because I was not able to capture it immediately. At the same time, for your learning packet, please refer to the announcement in our Facebook group, in which we would be dealing with Learning Packet Week 3 and Learning Packet Week 4. For Learning Packet Week 3, that would be the What's More part, Activity 3.1. And for Learning Packet Week 4, that would be What to Do, Part A and Part B. Please do use NoteBlock app in submitting your answers to avoid any problems, which is downloadable in the Google Play Store and even in the App Store. As for your performance tasks, you would simply be sharing your meal. It could be taken from the Google or it could be captured by yourself. It's not a requirement that you will be cooking your own food as long as you will be having a picture to incorporate on the meal. Then afterwards, explain why those biomolecules are present. So if you have said that those are carbohydrates, then how come that is already present? Then afterwards, write down your name and grade and section. So make sure to save that as a picture format or a JPEG format. For more information, everything is already uploaded in our Facebook group. For attendance and evaluation, make sure to click the link that I have sent already, which is looking just like this. So once again, thank you everyone. See you in our next meeting. Bye. I hope you had a good day.